Okay, so this is the how to solve the problem on the third set of homework problems on Connect. So uh, it has two parts, and I don't know if this is random for everybody. The values are random for everybody, but for mine, it says that the cube is made of platinum, and it has an edge of 2.8 centimeters. And the density of platinum, it gives me 21.45 grams per centimeter cubed. And the first part, part A, asks to calculate the number of platinum atoms in the cube. So uh, it starts off by saying it's a cube. So obviously, you know how a cube looks. It's three-dimensional, but it only gives you one edge value of 2.8 centimeters. So to get the volume of the cube, we're gonna need to square it. So for mine, 2.8 centimeters. So we're gonna cube it, which on mine equals, what is that? So it's gonna equal on mine 21.952 centimeters cubed. Hopefully that's visible. So that's pretty simple. Now, because it gives you the density, and you already have one of the units, you can basically start kind of canceling out things and converting the units. So, I'm going to go ahead and erase this. Forgive me, the computer's on my lap, and this is kind of like where my bed area is, so there's a lot of wiggling and bouncing. Okay, so the volume of my cube was 21.952 centimeters cubed. We're going to use the density, and which is I'm kind of consulting these sticky notes here that I wrote down. All right, 21.45 grams per 1 centimeter cubed. So that's the conversion it gives you. Gonna cancel those out. Oh, my bad. Cancel those out. And that's gonna give me 470.8704 grams. Okay. So we've gone from centimeters cubed to grams. Now we go from grams using the molar mass, which you're going to have to look up, or use a periodic table. So that's pretty simple. So the molar mass is 195.09 grams, right, per 1 mole of this substance, which is platinum. So after you convert it to moles, so you're gonna cross out grams. The grams cancel, and you're left with moles. So here I was left with 2.413 moles, and I used Avogadro's number, which is how many atoms or molecules there are in 1 mole of the substance. So, and that's a constant. So in 1 mole, there are 6.022 times 10 to the 23rd. In this case, it's atoms. Sometimes it's molecules. So, so the moles cancel out. And I am left with my answer for part A, which for me was 1.45 times 10 to the 24th platinum atoms. Okay, I really hope that's visible. I'm going to check, make sure. Yeah, okay, you can see that. All right, so that's the part A. So that's how many atoms there are in the cube. that we had earlier. That's pretty simple. You're basically just using the conversions. So the next part, it's I guess is considered the more difficult part because there's so many red herrings, and red herrings are really just things that they put in to kind of distract you, and like maybe you need them, but a lot of times they're common sense, and then when you kind of leave them out, you're just like you think you're doing something wrong, and so a lot of times you feel like you have to use some of the units that they give you when you really don't, which is just the way that they trick you. Okay, so it's basically saying that, you know, it is a cube, but atoms are spherical in shape. So when you put a bunch of spheres together, where they don't, where there's all this empty space in between them. Okay, and that empty space, well, really the solid space, it's really atoms. So the space that the atoms actually occupy only takes up 74%. So now you have to let's see, what do I do here? Okay, so you're gonna find 74% with the volume that you had earlier. So this is the way that I do percents. You know, people don't always do percents the same way. Oh man, did I use 75? I did use 75 for my calculations, and I still got the right answer. It's terrible. Anyway, so this is the way that I do my percents. I do 74, the percent that I want, over 100, because that's all a percent is. It's a fraction of 100. So it's 74 over 100 divided by the whole volume. Remember the volume of this cube, the what you calculated in the first part when you cubed the centimeters to 5, whatever that is. Okay, so this is going to be centimeters cubed. That really matters. Doesn't really matter. And again, that is 2.8 cubed from the beginning. So now you cross multiply. So you multiply 74 times this number, which is the volume of the cube, divided by 100. And what I got for this, which is probably off if you recalculate it because I used 75%, 464. So 74% of the volume is 16.464 centimeters cubed. So this is basically just the ratio. As you can see, they're equal. Okay. So that's how you find out how much is actually the space that the atom occupies. The opposite of that would be 26% empty space, which you could also calculate, but you really don't need to. So now what you do is you take this number. I'll go ahead and clean this up without trying to shake this screen too much. Okay. So you just calculated how much is actual space taken up by the atom, which is 16.464 centimeters cubed. Now, so that's for all of the atoms in the cube. So that's how much space is occupied by all of the atoms in the cube. Now you calculated in the first part the number of atoms. So you want to get this, how much space is occupied per one atom. So for only one atom, because that's what the question is concentrating on, as just one atom. So you're going to divide it by the total number of atoms, which is the answer for the first part. So for us, that's 1.45 times 10 to the, 24 platinum atoms. Okay, so when you divide it, it's essentially going to be over per one platinum atom. So when you divide this out, it will equal, let's see, what is this? 1.135 blah 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 times 10 to the negative 23rd. Okay. So now this is the volume, so this is in centimeters cubed per 1 atom of platinum, which is what we want because we're calculating only 1 atom, not in the whole cube. So a lot of the stuff in part B is just there. I mean, you kind of need it, but the mass, where it says the mass of a single platinum atom is blah blah blah, I tried to do a couple of calculations with that, which it should have worked in a certain way, but it didn't for some reason. I don't know. So now what you're going to do with this number, so that's the volume occupied by only one single atom, is you're going to set it equal to the volume of the sphere of a the volume of a radius. Yeah. What am I talking about? The volume of a sphere, because an atom we know is a sphere. Simple. Yeah, I already knew that. So the volume of a sphere is equal to 4/3 pi r cubed. And so you set these two equal. So yeah, I'm gonna see if I can quickly erase that. There we go. Yeah. All right. Cool. So again, that's 1.135 something. Yeah, 5 times 10 to the negative 23rd. So that's centimeters cubed per atom. Okay, so then equals 4/3 pi r cubed, right? So then you just divide it by 4/3, right? Make sure you use parentheses in the calculator or else it'll probably mess up. And then after that, you divide it by pi, right? And then whatever number you get there, you do the cube root of that, of the answer. So first you take this number, divide it by 4/3, then divide it by pi, and then take the cube root. If you don't know how to do the cube root, it's just math. Then you scroll down and number 4 should be cube root. It should be a 3. And then, you can start the cube, then you can start the root. Another way to do it is to type in 3 and then go to math, and where it has x to the root, that is basically saying x is the number that comes before it, so it'd be 3 root, and then you put in whatever answer you got for that, and here it should come out to, after you do all that, r, so you're isolating r. So r in this case will equal 1.394 times 10 to the negative 8th. And remember we started with centimeters cubed, but since we cubed it, it's just going to be centimeters. So, this is cubed, but eventually you're going to cube this side, or cube root of this side, and then you're going to cube root of this side, which also includes the units. So, yeah, you're basically uncubing the centimeters. And that should be the correct answer. Let me just double check, because if it's not, that's going to be embarrassing. Oh, yeah, one more thing. You got to change this to picometers, and I don't know how to do that off the top of my head, so the best way to do that is to go into Google and say 1.3 blah 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 centimeters to picometers, and it'll give you it in picometers. And you put that in, and that should be the answer, which I believe here was 1, because of just the way it is. It's 139 picometers should be the answer. So Looks like 1:39 p.m. Oh, okay. Anyway, yeah, so that hopefully it helps you, and I hope you could see everything. I don't know how clear it is, and I really hope the audio is coming through the mic. Okay, so I'm rambling on. Yeah, there you go. Awesome. Let me know if it works.